This is National 5 Maths Revision, and we're going to be looking at volume today, and this should help you for any assessments that you may have in January and February time. Okay, so let's look at these questions here. So the first one here is calculate the volume of the following shapes. So we've got two shapes here, we'll work out the volume of these. I think this one here should have a wee right angle in there, and it should show that it's a quarter of a cylinder. So don't get the cylinder formula in the exam paper. So we're just going to have to remember that. So the volume of a cylinder is going to be equal to pi r squared h. Okay, you can probably get that from the cone formula and just chop off the third. Okay, and you would get your volume of a cylinder formula from there. Let's put our numbers in. Okay, so I've got pi times the radius. So the radius is given, so that'll be my radius there. It'll be 14. I'm going to square that, then I'm going to multiply it by the height. So I can just imagine that that's lying up the way, so that's going to be 17, or it's the length. Okay, so into the calculator with that. Let's go for it. Right, calculator on, and hopefully you can see the calculator. Let's see if you can. I think so. I'll just tip it if I have to. So I'm just going to put in the pi button. I'm going to go for 14 and square it. I'm going to go for 17. What that will do is that will give me the volume of the cylinder. So the volume of the cylinder I've got there is 332 pi. Okay, and that's going to be in centimeters cubed. The thing here that I'm really after is it's a quarter of a cylinder. So it's a quarter of a cylinder. So I'm going to divide this by 4 here. So if I divide that by 4, I'm just going to divide it by 4 on the calculator. Divide by 4, and that should give me 833 pi. I'm going to write that down, okay, so you can see it, 833 pi. And then what we've got is we're just going to do the SD button, and that should give me my final answer there. So it's 2616. I'll write that full number down. I'm going to go for that. 2616.94668. And what I'm going to do with that one there, I'm going to look at the question. It's given in whole numbers, so I'm going to round it to 1 decimal place better than that. So I'm going to round it to 1 decimal place. 0.9. So that's to 1 decimal place, working in centimetres. Okay, so there's my units, that's there, cubic centimetres. And I'm just going to say that that's to 1 decimal place, okay? And that's my final answer. Okay, moving on to the next one. So the next one here, we've got a kind of odd shape. This shape is made up of, I can see, a cuboid and a half of a cylinder. So if I look at where the cylinder kind of starts, it's going to be there. And if I just go backwards from there, so that bottom part, if I can imagine that I can see through there, so there's my, getting carried away here a wee bit. Okay, so there's my cuboid that's sitting on the bottom, and I've got a cylinder that's sitting on the top. So let's go for the two parts of that. So what I'll do first of all is I'll go for the volume of the cuboid. So volume of the cuboid. So that's going to be just a length, breadth, height, isn't it? Length times breadth times height. So length, I'll just go for 5.2 metres. I'll multiply that by the breadth, which is 4, and then multiply it by the height, which is 2.8. I'm just going to fire that straight into the calculator. And what I should get there is 5.2 times 4 times 2.8. And that should give me my answer there. Press the SD button to give me my answer. And it's going to be 58.24. Okay, and that's in centimetres, and it's the cubed version of it. Okay, so that's the units that I've got there. So to work out the next part, and that's going to be the cylinder. So if I think about the volume of a cylinder, but remember that's only half a cylinder, so I'm just going to divide it by 2, okay? So the volume of half a cylinder is going to be equal to pi r squared h for a full cylinder divided by 2. So that's all I'm going to do. So pi times the radius. So remember here, all the way across is 4. So I think my radius here is going to be 2. Okay, so it's going to be 2 metres for my radius. So that would be 2 squared times the height. And the height of this, here we go. So from there all the way to there. So that would be the height or the length of it. So it's 5.2. And what I'll do there is I'll divide that answer there by 2. So I'm going to fire that into my calculator and get a final answer. So I've got pi button, times 2 squared, just 4, that would be times 5.2, and then what I'll do is I'll divide that by 2, and I should get my final answer. I won't put it down as pi, I'm going to put it down as that answer there. I'm going to write the full thing out again, so that's 32.6725636. Hopefully I've got that right, and that's cubic centimetres as well. So for the total shape, it's the total shape that I'm really after. So the total volume is going to be equal to the two of these added together. So that would be the volume of the cuboid plus the volume of the half cylinder. Okay, so what we've got, the volume of the cuboid, 58.24, and I'm going to add on to that 32.6725636. Good thing I've not cancelled my calculator, so in the calculator I've still got this number in here, which will be that one. All I'll do to that is I'm going to add on the 58.24 equals, and that should be my final answer. So I'll just write that down. Right, so I've not been asked to round that to anything in particular, so I'm just going to go one better than what I've been given in the question. So I've been given 1 decimal place, I'm going to round it to 2 decimal places. So that's going to be equal to 90.91 cubic meters. That's going to be, cubic meters. I'm going to change that up above as well, so that's cubic meters. So I just checked that there when I was writing out that answer. I'm going to go back and I'm going to change this, so that's cubic meters. Okay, and this wee guy over here is going to be cubic meters as well. Glad I spotted that one. Okay, so that would be to 2 decimal places. Okay, just one more accurate than what we've been given in the question. Right then, so there's the final answer that's there, and remember it's in cubic meters. Let's look at the next couple of questions we've got. Right, this one looks like quite a good one here. Okay, so what we have is we have a larger cylinder, okay, a cylindrical water container, radius 18 centimetres and height of 42 centimetres. Calculate the volume of this part here. So let's go for part A. So part A. Okay, so remember it's a cylinder. There's maybe too many cylinder questions in this this revision piece here, and we should look at spheres as well and also pyramids. We've got a cone here as well, so a different shape. We'll work these ones out. Okay, so the volume of a cylinder, and that's going to be equal to pi r squared h. Okay, remember you don't get that as a formula. So I'm going to put in my values, pi times the radius, which is 18 squared, and I'm going to multiply that by the height, so that's going to be 42. So into the calculator, I'm just going to go for that one, and what I should get out here is, so I've got pi times 18 squared, and I'll multiply that by 42. And what I should get there is hitting the SD button. I'll get 427, let's go for it, 42750.79283. Okay, and I'll just check the units this time, so it's centimetres and they are cubed. Okay, it's cubic centimetres. Right then, so that's part A complete. Okay, that's my answer there. I don't want to round that at this moment in time because I can see I'm going to have to use the value for here to work out the rest of this question that's here. So I'll go for part B. Okay, so part B. Start that in green. Okay, so part B. Right, so when full, this container can be used to fill 200 cone-shaped cups like the one shown. So like this cup here, calculate the radius of the cup. So first thing I want to do is to find the volume of that cup. Finding the volume, I know that 200 of these are made up of one of these. So what I'll do is I'll just divide that number there by 200, and that should give me the volume of the cup. So volume of the cup is equal to, I'm just going to take that number there, 42750.79283, and I'll just divide that by 200. And remember what that is there, that's the volume of the cylinder. Okay, so it's volume of the cylinder divided by 200. If I divide that by 200, luckily again, I've kept that in the calculator without cancelling out. So what I'll do is I'll just divide that number. So it's just pull the answer in, divide it by 200. And that should give me my answer here once I press the SD button. So that'll be 213. So it's going to be 213.7539642. And that's going to be in cubic centimetres as well. Right, I've not rounded that one either. I don't need to do that. Right then, so what I've got to do is I've got to work out the radius of that cup. So if I think about the formula for the radius of the cup, okay, let's think about the formula for the cone first. So remember, the formula for the cone can be found in your formula list, and what it will be is, so the volume of a cone is going to be equal to, it's like a cylinder but it's a third of it, so it's a third pi r squared h. So that's all it is. So if you're ever kind of trying to work out the cylinder formula, just cancel the third out of that and it's a pi r squared h. Okay, just like that one there that I was using. Right then, let's go and try to get this sorted out. So I'm going to have to rearrange this formula, okay, to work it out. So what I can do first of all is I can, let's go for it. I'm going to try and leave r on its own. So I'm going to multiply each side by 3. So I'll multiply this side by 3 and I'll multiply this side by 3. I'm going to do quite a few things at the one time. I want to get rid of the pi. So what I'll do is I'll divide this side by pi and I'll divide this side by pi. I'm going to divide this side by h to get rid of h and eliminate that. So I'll have to divide this side over here by h. So a wee bit complicated, but this is what it leaves me if I think about a line over there. So I've got r squared at this side is equal to, and I've got 3v all over pi h. And remember, that's going to cancel. The 3 and the 3 is cancelling, and the h is cancelling. So that leaves me with r squared. I don't want r squared, so what I'm going to do is I'm going to take the square root of both sides. And if I take the square root of both sides, so what I end up with is 3v all over pi h. And what I'll do is I'll substitute my values in. So my values that I'm going to substitute in, I've got 3 times this number that's up here. So it's going to be 213.7539642 all over pi times the height of it, and the height is 12. So that there in the calculator should work out to be my answer. So again, kind of luckily, I've kept the number in the calculator. So what I'm going to do is I'm going to just multiply it by 3 just now. So multiply it by 3 gives me the top line of that there. I'm then going to divide it by pi, and you would have to be careful here. If you were going to try and divide by pi and 12 at the same time, you need to put it in a bracket. But what I'll do is I'll first of all divide it by pi. Okay, there's the pi, press equals, and then I'll divide it by 12. Divide by 12, and 12, and that gives me that there. So what I've got is the square root, I'll just write that down, of that there. So which equals the square root of, let's see, it's going to be 17.01, and all I'll do is just do square root of that answer there. That should give me that value there. Okay, so what I've got is I've got 4.124318125, and that's going to be in centimetres. Okay, so, or what I can also say is if I want to do it to the nearest, let's see, I'll go to 1 decimal place for this one here. So this one equals 4.1 centimetres to 1 decimal place. Okay, and that would be my answer there. And that was what I've answered. I've answered the radius of the cup. So the radius of the cup is equal to that there. Okay, that's that done. So can I just show you very quickly another way that we could look at for, oh, I've just come off the page there, sorry about that. Okay, there's my working there for it. Just to show you a different way that you can work out the changing the subject to the formula for this type of question when they're all multiplying together. So we know that for the cone, I know the volume. So if I think of speed, distance and time, the way that that's kind of set up, it's set up in a kind of triangle, isn't it? So if I think about the volume of a cone being a third times pi times r squared times h. So they're the things. So volume equals a third times pi times r squared times h. If I was doing speed, distance and time, I could cover up the r squared that's there, and that will leave me with a formula that would show it's v all divided by a third pi h. So what I could say is there's r squared is equal to v all divided by a third pi, and that's going to be h. That's there. And that looks similar to this here, not exactly the same, but remember, if we're dividing by a fraction, you could flip the fraction. and change it to a times. So if I flip that over and changed it to times, it'd be times in by 3, and that's what that would be there. So basically this formula would work out to be volume all over a third pi h, and that's another way that I could work out that that answer that's there. Okay, sorry for going off the page there, but that's the answer for that question that's there. Okay, last question in this section, and what we've got is we've got 2 cylinders. They have the same volume, okay? Different dimensions. Calculate the radius of the second cylinder. So I want to know what the radius of this cylinder is here. Okay, so let's work out the volume of the first one. So volume of cylinder 1. Okay, we'll call this cylinder 1, this one's cylinder 2. Okay, and what we've got is pi r squared h. So I've got all the numbers for this. Radius is 7, and we'll square that, times it by the height, which is 5. What that should give me is, on my calculator, I'll just go for, so it's going to be pi times 7 squared times 5. Okay, and there's my answer there. So that should be 769. Okay, so let's go for that one. So 769.96020001. Okay, just going to leave that as it is. Working in centimetres, and because it's volume, I'm going to get my units correct there. So there's the volume of that one. Right, so I know that the volume of this one here equals the volume of that one. So again, what we've got is volume of cylinder 2. Going to be equal to pi r squared h. So to rearrange that formula around, I could do the same thing as I did up above, where I was thinking about, let's see, the volume is equal to pi r squared h. What I'd do is I'd cover up the r, and that would be v all over pi h. Okay, so what we'd have is v is equal to, sorry, we're working out r squared. So r squared is equal to v all over pi h. If I wanted to work that out properly, take the square root of it and pi h on the bottom there, like that there. Or what I can do is just the usual process. If I was working out a change of formula, what I would do here is to get r squared on its own, what I'll do first of all, I'm going to divide each side by pi. So if I divide that by pi, okay, what I've then got is I've got v over pi is equal to, they're eliminating, and that'll be r squared h. I'll then divide both sides by h, eliminates that, and I'll be dividing by h on this side here. So that gives me r squared is equal to v over pi h. I'm going to take the square root of it to find out what the radius is, and when I substitute my values in, I should be able to get my answer from there. Right, again, I've kept the volume in the calculator here, so I'm going to use that. So that's going to be the square root of 769.69020001, and that's all over, and it's going to be pi, and that's going to be times by the height, and the height is 8 on the second cylinder. Okay, so I could put that into a wee bracket there just to be a wee bit kind of clever, if that's what we're doing. So I've got this number in the calculator already. What I'll do is I'll divide that, and I'm going to divide it by that bracketed term there. So I could divide it by pi first, press equals, divide it by 8, press equals, and get the answer, or I could go for pi times 8. Just be really careful with this calculation that's here. So what I've then got is I've got this answer here. So that's going to be 30.625. Still to get the square root of that. So square root, answer, pulls that answer in, and that equals, it's here, press SD button. So that's going to be 5. Oh, we're nearly off the end again. 5.533985905. And I'm just going to go to one place decimal wise better than what we've been given. So that's going to be 5.5, and I'm going to say that's going to be in centimetres. Okay, centimetres to the nearest centimetre, to one decimal place that would be. Okay, so that's one way of doing that question there. There are other ways that we could do it. We could make both of these equal to each other, right? So there's another option. Like what we could say is that volume cylinder 1 is equal to the volume of cylinder 2. Okay, so and what we could do is we could say that the volume of cylinder 1 is pi r squared h. The volume of cylinder 2 is pi r squared h. But remember, that's cylinder 2, that's cylinder 1. I've got pi on both sides, so I could cancel pi out. I could then go and work things out with substituting values in. So just a different way to approach the question, and that's another way of doing it. That's quite a good way of doing it anyway, but certainly you would know how to go this way here. Okay, so that's the volume section complete. Too many cylinders in it for me at this moment in time. I think I would rather see a bit of variety in there as well. But hopefully that's been worthwhile and it's helped you understand the volume topic at National 5.